Welcome back, dear students, to this continuing lecture about serial communications. So, in the last video lecture, we were discussing about serial communications and how an 8051 microcontroller can be interfaced with the PC or a modem using this RS-232 interfaces and also this MAX 232 and MAX 233 ICs to make the microcontroller's TTL logic input output compatible with the RS-232 logics. And then we also saw how we can set the baud rate and what are the different you know different bits in the SCON register and what are their functions, what's the function of SBUF and so on. So we will continue from that point. So today we will start discussing about how to program the 8051 to transfer character bytes serially. So the first step will be, as I said, you have to set up the tmod register with some value. Okay, so that value has to be 20h because as you saw in the previous video lecture, the timer is used in the 8-bit auto reload mode or mode 2 to set the baud rate. Okay, so therefore the first step is to load the tmod register, or the timer mode has to be set to mode 2 by loading it with 20h, because for serial communication we always use the timer 1. Okay, so therefore 20h has to be loaded. Then the next step is to load the TH1 register with one of the values to set the baud rate for serial data transfer. Okay, so so just a second. Yeah, so as you saw in the previous video lecture, like to set the baud rate, you have to find out like what is the number that you need to load in the TH1 register. So that was found by dividing 800 by the required baud rate x, and then you will get a number n, and then you load your TH1 with 256 minus n. Let's say this number is m, and then the hex equivalent of this is loaded to your TH1. So the TH1 is loaded with one of the values to set the baud rate for serial data transfer. So that is your step 2. Then in step 3, the SCON register is loaded with the value 50h, indicating that you are using the serial mode 1. So if you remember, SM0 and SM1, these were the 2 bits in the SCON register, and you always set that to mode 1. Okay, so basically you set SM1 to 0 and SM0 to 1 actually. So this is the way to read it, SM1 and SM0. So 0 1 signifies mode 1, and this is the mode for that 8-bit data to be framed with one start and one stop bit. So that arrangement has to be done by loading 50h to SCON register. So that is your step 3. In step 4, you start the timer. So TR1 is set to 1 to start the timer, and then the timer will count the value starting from this number to 256, and this will set the baud rate. Okay, and within this time the entire serial data transmission will happen, and then when the serial data is transferred, the TI flag will get automatically raised. So in your step 5, the TI has to be cleared by using this clear TI instruction. The oh sorry, this is before the transmission. So first you have to ensure that the TI flag is cleared. So that is your step 5, and then the actual character byte to be transferred is written into the SBUF register. So as soon as you place the character byte in SBUF, it frames the byte and starts transmitting it serially. And after the transmission is finished, so at step 7, the TI flag will be raised. Okay, so the TI flag needs to be monitored with the use of this instruction JNB TI XX. So this means jump on no bit. So as long as the TI flag is 0, you don't do anything, but when the TI flag is raised, then you have to do something else. So this TI flag is monitored with the use of this instruction to see if the character has been transferred completely, and then the transfer of the next byte is done. So you have to go back to step 5 and then you repeat the steps. Okay, so let's see all these steps through an example. So let's assume that you are asked to write a program for the 8051 to transfer the letter A serially at 4800 baud continuously. Okay, so the first few steps are same. So you have to load the TMOD with 28, so to ensure that it's in mode 2 or auto reload. Then since your baud rate is 4800, so you have to load, so you have to make it a divide by 6 counter. So 2800 divided by 4800 is 6. So basically you have to divide 28800 by 6 to get this baud rate, right? So to make sure that it's a divide by 6 counter, you have to load the number 250 in your TH1, and that is equivalent to FA in hex. So it will count from 250 to 256 and then it will roll over. You have to load the SCON register with 50H to ensure that it's an 8-bit one stop, and the RAIN is also enabled to make sure that it's it can receive the data, and then you start the timer. Okay, so by setting the TR1, and then you are moving the letter A, which is to be transferred to the SBUF register, and then that's it. The serial communication will start as soon as you place your data into the SBUF register. All you need to do is now to monitor the TI flag. So you are monitoring the TI flag. So as long as this TI is 0, you are staying here on the same line. Okay, you are doing nothing. As soon as the last stop bit is getting transferred, this TI flag will be raised to 1, and then you go away from this line to the next line where you are clearing the TI flag to be ready for the next serial transmission, because your code says that you have to do it continuously. So you are clearing the TI flag and then you are jumping to this step again. So you are placing the data into the SBUF register again, and the transmission of the character A continues. Okay, so this is an example of coding your 8051 for serial communication. So we will extend the concept that we saw in the previous example code, where we have to now transmit three alphabets, okay, corresponding to this word yes. So write a program for the 8051 to transfer yes serially at 9600 baud 8 bit of data, one stop bit, and then do this continuously. So again, for this the first few steps are same. So you are loading tmod with 20h so that your timer 1 is in mode 2. You are loading th1 with 0fdh to ensure the baud rate of 9600. You are loading scon with 50h to enable this particular mode, and then you're starting your timer 1, and then here you are performing the same task thrice. So it's better to write a separate subroutine called trans, okay, for the serial transmission. Okay, so you are loading the first letter y to your accumulator a, and then you are calling the trans subroutine. You are loading the next letter, you are calling the trans subroutine again, and finally you are loading the final letter and calling the trans subroutine, and then you are repeating the operation by jumping to this line again. Okay, so this is happening continuously. Now let's look into the trans subroutine, what is happening here. So here basically whatever you have in A, you load that to SBUF. So basically you are loading the data to be transmitted on SBUF. So every time you are loading the letters to A, and then you are calling the trans subroutine, and inside the trans subroutine you are loading whatever is in A to the SBUF, and as soon as you place that to SBUF, your serial transmission starts at this point, and you are monitoring the TI flag to see if the transmission is finished. So as long as the transmission is happening, the TI flag will be 0, and you are staying in this particular line which is labeled as here. As soon as the serial transmission finishes, the TI flag will be raised, and then you jump to the next line, and you have to clear the TI flag so that the next serial transmission can happen, and then you have to do this continuously. So you are clearing the TI flag, and then you are returning back to the main program. So this is how you can serially transfer multiple characters using serial communication. So the different steps of serial transmissions are as follows. The byte character to be transmitted is written into the SBUF register. Then the start bit is transferred. Then the 8-bit character is transferred 1 bit at a time. Then the stop bit is transferred. It is during the transfer of this stop bit that the 8051 raises the TI flag, indicating that the last character was transmitted. So therefore, by monitoring the TI flag or using the interrupt, we make sure that we are not overloading the SBUF. Okay, if we write another byte into the SBUF before TI is raised, then there is this chance that the untransmitted portion of the previous byte will be lost. Okay, so you have to wait until the previous byte is fully transmitted, and that is ensured by raising the TI flag. So you have to wait until the TI flag is raised, and this waiting can be done by either monitoring the TI flag or using the serial communication interrupt. So whenever the TI flag is raised, you can trigger the serial communication interrupt. So we will see the example of interrupts later on in this lecture. Now after the SBUF is loaded with a new byte, the TI flag bit must be forced to 0 by clear TI in order for this new byte to be transferred. So the TI flag, unless and otherwise it is cleared to 0, the serial communication will not happen, even if your SBUF is loaded with a new byte. So this is also a very important thing to note. Okay. So how will you program the 8051 to receive a character? So now that we have discussed about transmitting, let's see how to program the 8051 to receive a character byte serially. So the first few steps are same as you see. So the TMOD register has to be loaded with 20H to set the timer 1 into mode 2. The TH1 has to be loaded to set the baud rate. The SCON register is loaded with 50H to indicate that you are in serial mode 1. The TR1 is set to 1 to start the timer, and then in case of receiving, your RI flag becomes important. So in step 5, your RI is cleared by clear RI instruction, and then the RI flag bit is monitored with the use of this instruction, similar to what we did for transmission, to see if an entire character has been received yet. And when RI is raised, SBUF has the byte. Okay, so its contents are removed into a safe place, and then to receive the next character we go back to step 5. Okay, so let's see an example. Write a program for 8051 to receive bytes of data serially and put them in port 1. Set the baud rate at 4800, 8-bit data and 1 stop bit. So 8-bit data 1 stop bit means you have to set it to mode 1, so that you do by moving 50H to SCON, and then you are setting the TMOD to 20H, so that timer 1 is in mode 2. You are setting TH1 with 0 FA to set the 4800 baud rate. You are starting the timer 1, and then you are monitoring the RI flag. As long as it is 0, you are staying in the same line, which is labeled as here. Once the reception is complete, your RI flag gets raised, and then you move to the next line. In the next line, you have already the data that is received in your SBUF, so you need to save the incoming byte in the accumulator. Okay, and then you send that byte to port 1 as asked by the question here, and then you have to clear the RI flag so that you get ready to receive the next byte, and then you jump to this line. Okay, to receive the next byte. Okay, so this is how you program for receiving data in serial communication. Now let's look into a more complicated example. So let's assume that the 8051 serial port is connected to the COM port of an IBM PC, and on the PC we are using the terminal.exe program to send and receive data serially. Port 1 and port 2 of the 8051 are connected to LEDs and switches respectively. Write an 8051 program to do the following. What are those? First, send to PC the message "we are ready". Then receive any data sent by PC and put it on LEDs connected to P1, and get data on switches connected to P2 and send it to PC serially. The program should perform part A once, parts B and C continuously using 4800 baud rate. So this is a very complicated um, code. Like, lot of things are asked to be done. So you should first analyze the code. Analyze the question and see what are the things that you need to do, and then you break it into parts and then do or write the code for the different parts one by one. So let's say, so this is the arrangement that you want to achieve as per the question. So your serial transmission port is connected to PC, and the reception port is connected to the COM port of the PC. Okay, and then your port 1 is connected to some LEDs and port 2 is connected to a set of switches. Okay. So this is the code actually. So let's first look into it one by one. So before looking into the entire code, you can see that we have different subroutines here. So this is the subroutine for sending serial data. Okay. So or serial data transfer. So this is the send subroutine, and this is the receive subroutine for serial data reception. Okay. And you are using these in the main program intelligently. Okay. So so let's see what we are supposed to do. So first thing we have to do is, if you go back, you have to write an 8051 program to send to PC the message we are ready. Okay. So your PC is connected to the serial transmit port of 8051. So you have to basically send the message we are ready using this serial transmit port to the PC. So basically we have to send these characters, so W, E, A, R, E one by one. So these are all 8-bit characters. So you have to send all these characters one by one serially to the PC. So that's the first part. Okay, so let's see. So we have the send subroutine, we have the receive subroutine, and we have the message location we are ready in this memory location, which is indexed by my data. Okay. And then after all the characters of the message, we have also a 0. Okay. So this indicates the end of the sentence here, we are ready. This 0 works as a full stop or a period. Okay. So so now let's see how we are using these concepts here to send we are ready serially. So first thing is that you make P2 an input port. Okay, by sending 0FF to P2. Okay, because you have to read data from P2. P2 is the port which has the switches connected to it. So whatever is there on P2, it has to be sent to the PC serially. Okay, so P2 has to be configured as an input port. Okay, so this part is getting done here. Okay, first. Okay, then you are loading tmod with 20H. So timer 1 in mode 2. This is a standard step for serial communication coding. You are loading TH1 with 0FH because your baud rate has to be 4800. You are loading SCON with 50H because this is the 8-bit one-stop mode or mode 1 of serial communication, and then you start the timer. Okay. So now what you are trying to do is you load your DPTR with the starting address of this memory. Okay, where your we are ready, this sentence is stored. Okay, and then you are using this indexed addressing mode. So first you are clearing the accumulator, and then you are using the indexed addressing mode to get the first character, which is W. Okay, to your accumulator A. Okay, by using this line. Okay, and then you are using this jump on 0. So when you are moving this character W to your accumulator, the accumulator is basically non-zero. Okay, so jump on 0 to B1 means whenever you find a 0 in the accumulator, it will jump to this line. Okay, and that's why there is a 0 here at the end of the sentence. So this means you are bringing these characters one by one into the accumulator, and whenever this 0 comes, okay, you are stopping. So that's why jump on 0. So if the last character gets out, the 0 will come to the accumulator and then it will move to the next step, okay. But otherwise, unless the accumulator is 0, it will get all these characters W, E, A, R, E. So we are ready. All this will be moved to the accumulator, and then you are calling the send subroutine so that the serial data transfer is happening, okay. And then this is the part where the serial data transfer is happening. So you are moving the accumulator data to SBUF, and then the serial data transfer starts. You monitor your TI flag, and as soon as the first byte is transferred, you are clearing the TI and returning to the main program. And then you are incrementing the DPTR. So the DPTR will now fetch the next character E using this indexed addressing mode to the accumulator, and then that will be serially transferred. So until you finish, transferring all the characters that you have for we are ready, you stay in the loop. So you are jumping back to H1, and then you are fetching the next character, waiting until it is 0, and transmitting it serially using this ACALL send, increment the DPTR, bring back the next characters, and then keep transmitting all the characters of we are ready until you figure out a 0, okay. When you have a 0, you jump on to the next part of the code. The next part of the code is to read the data from port 2. So you have some switches connected to the port 2. So whatever data is placed on port 2 by pressing these switches, that is brought to the accumulator A, and then you transfer it serially to the PC by ACALL send, and then get data from the PC by ACALL receive, and display that data whichever you have received on port 1 in the LEDs that are connected to port 1, okay. And then you are repeating this continuously, okay. So see, many things are happening in this code, okay. So by first writing a subroutine for send and receive, you can see you are using them multiple times. You are using it here, you are using it here, and then you are using here, and then you are structuring your code in a way as suggested by the problem definition. So this structuring of the code is very important. So this part, sending we are ready, is done once, okay. So this part, and then this part, which is whatever data you get on port 2, send it to the PC and get back data from PC and display it on port 1. This part has to be done continuously, okay. That's what your problem definition asked for. You can see the program should perform part A once, but parts B and C continuously. So this is happening continuously, this part. This is for part B and C, and this is for part A, and okay, and you have these subroutines to help you to structure the program, okay. So this is a classic example of how to do many things inside a code for your 8051. So we will move on and we will see what are the steps for serial receiving. So first step is that it receives the start bit, okay. Then the next step is that the 8-bit character is received 1 bit at a time. Then when the stop bit is received, when receiving the stop bit, the 8051 makes RI flag equal to 1, indicating that an entire character byte has been received and must be picked up before it gets overwritten by an incoming character. So this is important. Checking the RI flag bit, so when the RI is raised, we know that a character has been received and is sitting in the SBUF register. So we copy the SBUF contents to a safe place in some other register or memory before it is lost. After the SBUF contents are copied into a safe place, the RI flag bit must be forced to 0 by clear RI in order to allow the next received character byte to be placed in SBUF. Failure to do this causes loss of the received character. So this is also important. By checking the RI flag bit, we know whether or not the 8051 received a character byte. So if we fail to copy SBUF into a safe place, we risk the loss of the received byte. It must be noted that RI flag bit is raised by 8051 when it finishes received data, and it must be cleared by the programmer with instruction clear RI. If we copy SBUF into a safe place before the RI flag bit is raised, we risk copying garbage. Okay, so the RI bit can be checked by either this instruction or using the interrupt. So we have not gone to the serial interrupt part yet, but we will soon do that. So you can increase the baud rate also. So there are two ways to increase the baud rate of data transfer. So you can either use a higher frequency crystal, or you can change a bit in the PCON register. Okay, so the PCON register is an 8-bit register, and when it is powered up, this SMOD field is 0 by default. We can set it to high by software and thereby double the baud rate. So you can make the PCON bit high by writing a code like this, and then that will double the baud rate. So when your SMOD is equal to 0, the UART does a divide by 32 operation, and then you have a 28800 Hertz for the timer 1. But when your SMOD is 1, the UART divides by 16 and you get a 57600 Hertz for your timer 1. So this is double, exactly double of this one. Okay, so so yeah, and when you load your TH1 with these values, so you can get these baud rates when your SMOD is equal to 0, and exactly double the baud rates when your SMOD equal to 1. So you can have a program where you can do this inside the program. So let's say, assume that the crystal oscillator is 11.0592 megahertz for the following program. So state what this program does: compute the frequency used by timer 1 to set the baud rate, and then find the baud rate of the data transfer. So basically this program transfers the ASCII letter B continuously. So as you can see here, it's placing the letter to A, and then it's transferring it serially. Okay, so so with crystal frequency 11.0592 and SMOD equal to 1 in the above program, we have the frequency used by timer 1 as this. So the baud rate is 19200. Okay, because here your TH1 is loaded with FD. This is ATH, okay, not G. So so therefore baud rate is 57600 divided by 3, which is 19200. Okay. So we can see another example where, let's say, you are asked to write a program to send the message, the earth is but one country, to serial port. Assume a switch is connected to pin 1.2, monitor its status and set the baud rate as follows. So when your switch is 0, you have this baud rate 4800. When your switch is 1, you have 9600 baud rate. Okay, so so you define the bit 1.2 with the parameter called SW. Okay, so so this is what you are doing, and then your code starts here, and then these are the usual steps. Setting the T mod, so that timer 1 is in mode 2, then you load TH1 to set the baud rate, then you load SCON with 58, start the timer, and then you are making switch as an input. So basically your port 1.2 is defined as this SW, so you are setting that to 1 to make it an input pin. Okay, so as you know that whenever your port needs to be configured as an input, you have to place a 1 in that port. So that's what is happening in this line. Excuse me. Now you are monitoring this switch. Okay, so JNBSW, so check the switch status. Okay, and as long as it is 0, you are going to the line called slow SP. Okay, however, if it is 1, let's say, then it goes to this line. Okay, where you are, by this 3 line, you are basically setting the SMOD high to set the higher bit rate. So whenever your switch is 1, you have to set 9600 baud rate. So the default baud rate is 4800. That will be doubled when your switch is equal to 1, and by here in this line it's monitoring the switch. As long as it is 0, it's going to a line called slow SP. So that line is in the next slide. But if it is 1, then it will go immediately to this line where it is setting the baud rate to high. Okay, by making these adjustment in the PCON register, and then it's jumping to the line called over. Okay, so let's see what are those lines. Okay, so jumping to over means here where the actual message is getting sent. Okay, and the slow SP is this line where you are setting the SMOD low for 4800. So if your SW is 0, then you go to slow SP where you are setting it for 4800. If your SW is 1, then you are going to this few lines to set the baud rate to 9600, and then when you are done with those 2 scenarios, then you are going to the line labeled as over where your actual serial communication happening. So you have the entire message, the earth is but one country, followed by a 0 in this particular memory location denoted by MESS1. So you are fetching the first character from this memory location to your DPTR, and then you are using the indexed addressing mode to, you know, read the value. So the first character will be T, that will be brought to the accumulator, and then you are, if your accumulator is 0, which will happen when you have this last character, after the last character Y it will be 0, so then it will jump on to S1. Okay, so where is your S1? Check for end of line. Okay, S1 is not shown here, but let's say if you have 0, then it will go to the S1, but if it is not 0, it will do the serial communication by a call CENDCOM, where CENDCOM is the serial data transfer subroutine, and then it will increment the DPTR and then keep repeating this line. Okay, so this is the entire code except this S1 line. So the S1 line could be somewhere here, where if your end is reached, then you do nothing. Okay, so let's say this one has to be, you can do, let's say, so if your end of line is reached, then basically you do nothing. So you can write your S1 somewhere here, and then you can say no operation. Okay, so this is your entire code here. Okay, for this particular example, where you can switch your baud rate between two values depending on the status of this switch. Okay, so now we will move to the serial communication interrupt. Okay, so in the 8051 there is only one serial communication interrupt. Okay, set aside for serial communication. So this interrupt is used to both send and receive data. Okay, so if the serial interrupt bit in the IE register is enabled, then when your RI or TI is raised, the 8051 gets interrupted and jumps to memory location 00238. So this is the location for the interrupt service routine associated with your serial communication. Okay, so so we must examine in the ISR whether it's a TI or the RI flag that has been raised, to see which one caused the interrupt and respond accordingly. Okay, so since we have only one interrupt, so this is the logic for triggering to the interrupt. So if your TI or RI, whichever gets triggered, you will be interrupted. Okay, so inside the ISR you have to check whether it was due to TI being triggered or due to RI. Okay, so the serial interrupt is used mainly for receiving data and is rarely used for sending data serially. Okay, so this is like getting a telephone call in which we need a ring to be notified, but if we need to make a phone call, there are other ways to remind ourselves and there is no need for ringing. So however, in receiving the phone call, we must respond immediately no matter what we are doing, or we will miss the call. Okay, so let's see an example. So write a program in which the 8051 reads data from P1 and writes it to P2 continuously while giving a copy of it to the serial COM port to be transferred serially. Assume the crystal frequency to be this, and the baud rate is 9600. So so you have this code here. So you can see that in the main code, let's first focus on the main code. So the main code has these usual steps. Okay, so you are configuring P1 as an input port, you are loading TMOD with 20H, TH1 with this value to set 9600 baud rate. SCON is set to this so that this particular mode is enabled. Then you are moving this number to IE, the interrupt enable register. So if you recall your concepts, what you learned in the interrupt lecture, so the IE register has to be configured like this to enable the serial interrupt. Okay, and then you start the timer, and then you read data from port 1, move it to A, then from A to SBUF, and then send it to P2. Okay, and then you stay in this loop indefinitely. Okay, and then you, whenever the TI or RI flag is raised, okay, then your interrupt will be, you know, triggered, and you will go straight to this location in memory. Okay, so here you are using this one single line long jump to serial, so it jumps to the serial interrupt ISR. So this concept we have discussed a lot when we were doing interrupts. So inside this location 23H there is very little space to write a long program, so therefore it's always wise to jump to a safe location. So whenever the interrupt is raised, you move here in this location, and then you find this lines long jump to serial, so you long jump to this serial communication subroutine, which is basically monitoring the TI flag, and then jump if TI is high. So if the interrupt is due to TI being high, then it goes to this line where it clears the TI and then return from the interrupt service routine. Otherwise, if this is not the case, then the other possible case is that RI has been raised, and if RI has been raised, then there is some data waiting in SBUF which is received, that has to be moved to A, and then you clear RI, and then you go back to the main program using return I. Okay, and you can see also that the main program is jumped to a location 30H to bypass the entire interrupt vector table. Okay, so whenever you are using interrupt, this has to be done. So the main program cannot start from 0000H, it starts from 30H, and you are bypassing it by using this command. Okay, so this is the entire code that can be used for this particular example using the serial communication interrupt. Okay, let's see another example. So write a program in which the 8051 gets data from P1 and sends it to P2 continuously, while the incoming data from serial port is sent to P0. Okay, assume that crystal frequency is this and the baud rate is 9600. So here is the code. So you have this usual parts here. Okay, and then you read data from port 1 and send it to P2 and then do it continuously, and then whenever there is a interrupt, you go to this line, and then you long jump to the interrupt service routine where you are monitoring the TI flag if it is high. If the TI is high, you just go to this line, clear the TI and return to the main program. Okay, if the TI is not high, then the RI must be high, and therefore you have to receive whatever is in SBUF to A and send it to P0. Okay, and then you clear the RI and return back to the main program. Okay, so we'll see another example. Write a program using interrupts to do the following: receive data serially and send it to P0, have P1 port read and transmitted serially, and the copy given to P2, make timer 0 generate a square wave of 5 kHz frequency on P0.1, assume crystal frequency of this, and the baud rate of 4800. So here you can see For serial communication we use the timer 1 anyway, okay, and you have to use timer 0 to generate a square wave also, so you are doing multiple things together. So here you have to use interrupts. So the first part is to long jump the interrupt vector table. So your main program starts from 30H, and this is the starting line of the main program. So you are making P1 as an input port, and then you are loading TMOD this time with 22H, because your timer 1 is in mode 2 and your timer 0 also is in mode 2, because your timer 0 has to be used for the square wave generation. So that's why this is 22H, not 20H, unlike the other examples. Here you are using both the timers. Then you are loading TH1 with this number to set this baud rate. You are loading SCON with 50H for this serial communication mode, and then you are loading TH0 with this number for 5 kilohertz square wave generation. Okay, you are enabling the serial interrupt, okay, and you are starting both the timer. One will be used for the serial communication and the other will be used for the square wave generation. Then you read data from port 1 and send a copy to SBUF, and that will start getting transferred serially, and you also send it to port 2, and then you keep doing this continuously. And then inside your interrupt service routine for serial communication, you are monitoring the TI. If it is high, then you just clear it and go back to the main program. If your RI is high, then you receive whatever is in SBUF and send it to A, then send this serial data to P0, and then you clear RI and go back to the main program. Okay, so this is it for this lecture. We will stop here, and then I will see you in the next video lecture. Okay, and if you have any doubts, I will be answering them in the live sessions. Okay, so I'll stop here today. Thank you.